Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Tarek O'Dali from Business Review, and I will be your host. It is our pleasure to have Netronome with us today, who'll be presenting this webinar titled Accelerating Server-Based Networking for Contrail vRouter. Today's guest speakers are Daniel Proch, Senior Director, Solutions Architecture, Mark Rappaport, Senior Product Line Manager, Contrail, Glenn Hunt, Principal Analyst, Technology and Software, Global Data. I'd like to welcome you all to our webinar platform, ON24. You'll notice this webinar is fully browser-based, so if you do disconnect for any reason, simply click on the link you received via email and you'll be able to rejoin the session. In order to ask questions, you can send them in at any time via the questions widget. Just type them into the box at the top left-hand corner of your screen and click submit. We'll try to allocate some time at the end of the session to address any of the questions or thoughts you may have. Please use the yellow help widget at the bottom of your screen if you do require technical assistance, and you can also move, resize, and maximize any of those windows in front of you to get a better view of the slides. But now, please allow me to welcome today's first speaker, Mark. Mark, over to you.
Thank you. Good morning, everyone. My name is Mark Rappaport. I'm Senior Product Line Manager in Juniper. I'm focusing on service provider strategy and telco customers in the Contrail business unit. And today I'm going to give you an overview of what is Contrail networking, why does it matter in the context of data center and cloud infrastructure. And I'm also going to give you a quick introduction on Contrail architecture. After that, my colleague Daniel from Netronome will present the Agilio product, and then Danny will focus on the benefits that Contrail vRouter acceleration provides. Okay, before talking about Contrail networking, I'd like to very quickly cover the use cases that Contrail enables across the three main segments that our product targets. So let me start with the service provider segment, which is obviously an area where Juniper's leadership in routing, switching, and security is recognized. The typical use cases that Contrail enables are around NFV, distributed telco cloud, and its different variations. So historically, with Contrail, we saw a lot of interest in mobile packet core virtualization, including the services on the GI line side, like DPI, firewall, and content optimization. More recently, there has been many discussions around virtualization of the services in the branch, whether it's through a centralized model using virtual CP or in a more distributed fashion like SD-WAN. And last but not least, the taking up of IoT and machine-to-machine is pushing service providers to distribute the virtualized workloads even closer to the end user or to the end device, whether because of the need to provide a very low latency service or to limit the bandwidth impact of having to backhaul a massive amount of analytics data that are generated by these end devices. What these telco use cases have in common in terms of requirements are the need to connect virtual networks using security policies among many distributed DCs. And typically in large tier one telcos like AT&T Integrated Cloud, for example, each POP is becoming a mini data center. So we are talking about potentially hundreds or even thousands of distributed data centers. The need to provide dynamic service chaining for virtual network functions like firewall, IDS, IPS, or other security network functions. So dynamic service chaining here means the capacity to steer each flow through a chain of VNFs. And by the way, not limited to virtual functions, but also potentially physical network functions to manage legacy investment in appliances. And another requirement is to automate the deployment of the services and the creation of the virtual network and service chain through well-defined APIs. In the enterprise segment, there are three main use cases being considered. First one is IT as a service, which is allowing enterprise user to create and manage compute, storage, and networking resources, either through a web portal or potentially using APIs in the case of app developers. It's also about connecting workloads that run in the private data centers to apps that run in the public cloud or in a virtual private cloud like AWS or Azure. And finally, it's about allowing migration of workloads across different private orchestration like VMware to public cloud provider. And so these are the requirement for these use cases is to provide secure connectivity for legacy applications that run on bare metal, on VMware, using virtual networks, and at the same time using very granular security policies for each application, the famous microsegmentation. And last, you need to interconnect private cloud to public cloud and be able to extend these security policies to the workloads that are being run in the public cloud. Now, if we talk about the cloud provider segment, there are two main use cases. The first one is software as a service, which is pretty much any SaaS company that is developing and deploying their own application in a web-scale data center. The other use case being a cloud infrastructure provider that resells infrastructure as a service, whether these resources are virtual machines, containers, or even potentially bare metal servers. What the cloud providers need to do is a capacity to launch VMs or container and connect them into virtual networks by providing DHCP, DNS, IP management at a very high scale and at a very high rate of setup, especially in the case of containers, which are short-lived. Typically, the next generation of application developers develop stateless microservices that run containers that require autoscale and rely on DevOps infrastructure to completely manage the life cycle of the application. And that's where we see container orchestration frameworks like Kubernetes or Mesos being deployed. In the case of an infrastructure provider, we also see the need to automate the provisioning of the underlay to deliver bare metal as a service type of services. So what we've seen is that there are a number of differences, but also quite a few commonalities across the three segments, telco, enterprise, and cloud provider. And if we combine and summarize all these requirements, we see that networking is really critical because it's a glue that is connecting all these different application endpoints together, whether these endpoints are running on VMware virtual machines or bare metal servers using VLAN inside a legacy data center, or whether these endpoints are Docker container, VMs running in Linux KVM, or bare metal that need to be service chain through virtual network functions across multiple data centers, or whether these endpoints are actually containers or VMs in the public cloud provider like AWS or Google Cloud. Or finally, the endpoint could also be a CP router on a customer branch office of an enterprise VPN. Once the service overlay is in place, you can deliver all the use cases I've covered previously, like legacy interconnect for bare metal, VM or containers across multiple data centers, but also manage connectivity inside cloud providers, and also deliver all the telco cloud capabilities. Finally, what you need is obviously the support of a northbound API that can be consumed by various orchestration systems, whether it's OpenStack, Kubernetes in the case of container, or any other commercial orchestration system like IBM, Oracle, or actually even Juniper, as we have our own orchestration system for VNFs. So what is Contrail in a nutshell? Contrail is Juniper's cloud network initiative, which is based on an open source project called OpenContrail. And by the way, you can go to www.opencontrail.org if you want to have more information. So this open source project is under Apache V2 license. It's built on fully standard and open protocols like BGP, XMPP, NetConf, or VSDB, which allows interoperability with a rich ecosystem of vendors at the different layers, infrastructure, routing, switching, so on and so forth. Contrail provides all the components that are needed to implement network virtualization across any type of data center and cloud environment, KVM, ESXi, bare metal servers, or containers. Contrail is fully API-driven. API is really the first-class citizen here. There is not a single capability that is not configurable or managed through these well-documented API. And actually, the CLI and the web user interface are actually using these APIs in the backend. So why is that important? It's because it enables provisioning and policy automation across any type of orchestration system. OpenStack Neutron API being a well-known example, but also Kubernetes Mesos for containers, Amazon or Google Cloud Platform APIs. And obviously, these REST APIs can be consumed also by any custom orchestration system. And actually, most of our customers are actually using Contrail in this scenario. AT&T, for example, is using the eComp product that relies heavily on Contrail APIs to manage this whole layer. And last but not least, Contrail is a truly carrier-grade platform for cloud infrastructure. And what I mean by this is that compared with some SDN vendors that who are relying on OVS for their data plane, in our case, we wrote our vRouter data plane component from scratch and optimized it from the beginning to be a high-performance switching and routing platform, and at the same time being able to apply security policies without performance degradation. A lot of products that do that typically experience a significant decrease of thwarting performance when the number of routers, virtual networks, flows, or security policies increase. In our case, our thwarting performance is nearly constant when you scale in these dimensions. And talking about scaling, another key factor is that we design our control plane to handle thousands of virtual networks, millions of routes, thousands of compute nodes, and it can scale by adding more control nodes horizontally. Obviously, it's designed with high availability in mind. There is no single point of failure, and it has capabilities like in-service software upgrade to really bring down downtime to a minimum, and other high availability aspects I'm going to cover in the subsequent slides. And last but not least, the key component of our solution is the analytics engine, which is critical to operate the overlay network and being able to monitor and troubleshoot what's going on in the network. Okay, so how does it work? So first of all, at the bottom, we have a vRouter component, the data plane part of the solution that is forwarding traffic and applying policies inside each server. And it applies all these services to a collocated VM and containers in the server. To manage bare metal servers, we provision directly the top-of-rack switch that connect the server and the data center gateway to provide connectivity outside of the data centers. So all these vRouters or top-of-rack switches are managed by the control plane, which can also manage physical router and switches, obviously Juniper MX routers or QFX switches are supported, but also Cisco routers or other router vendors. And we support Arista switches, let's say white box switches running Cumulus OS, for example. And on top of this control and configuration layer, you can apply the whole range of control services, obviously related to switching or layer 3 routing, DHCP, DNS, IP address management, but also a number of native distributed services that are directly implemented at the vRouter layer, like layer 4 stateful firewall, load balancer, service chaining, security policies, quality of service, analytics, and so on. And on top of this, you plug the various orchestration systems, OpenStack, Kubernetes, Mesos, or maybe your homegrown orchestration, which happens for some of our customers. Okay, I just want to highlight the main control capabilities. I've already covered some of them, but just to give you a full picture of the feature richness of our product, besides obvious switching and v4 and v6 routing, we are implementing all the OpenStack Neutron services, obviously, like DDI, floating IP, source NAT. We also implement all the QoS, classification and queuing capabilities, but also BGP as a service, which is a capability of having a BGP peering session between any vRouter and the collocated VNF. This is quite useful when the VNF is actually participating to your routing plane to, let's say, manage redundancy, for example. That's a typical example we see with a virtual packet gateway. We also implement a distributed layer for load balancer at the vRouter layer, and we ensure that flows are evenly distributed and in a consistent manner to make sure that return path always match forward path for specific flow. Obviously, this is a key requirement for stateful VNFs, like a virtual firewall, for example, which would not be able to maintain states otherwise. On the security front, I've already talked about security groups and distributed firewall that is implemented by our vRouter. We also encrypt all the control protocols between the different control components. Performance and scaling, this is something I already briefly touched, but to expand a bit in terms of performance enhancement, our vRouter can run either in the host OS kernel or in the host user space and leverage DPDK to bypass the kernel and significantly improve the performance in software. But another solution to significantly improve forwarding performance, and that's what my colleague Danny will cover in deep details just after me, is the usage of SmartNIC. Gateway services, this is the capacity to integrate with bare metal environment or to connect directly to the underlay from our vRouter, what we call software gateway. Rich analytics. Here, what is important to understand is that every single flow that goes through the vRouter is tracked, aggregated, and collected by our analytics engine. And among other things, it allows to do real-time monitoring or replay historical traffic view. You can use the analytics engine also to do underlay overlay correlation, which is visualizing the exact path that a specific flow has been using between two endpoints, and not just across the vRouters, but also the underlying switches and the routers in the underlay. Service chaining, which is obviously a major requirement for any kind of telco and AV use case. And here we implement it using standard BGP mechanism. And even though all BGP policies are automatically compiled from a high-level intent-driven configuration that actually abstracts all the complexity, and all this is being done under the hood by our configuration engine, it's funny to see that more and more of our customers, especially the service providers, want us to expose more and more of the BGP knobs to be able to fine-tune all the routing and chaining policies. High availability upgrade, I already pretty much covered most of it. And last but not least, API and orchestration, which is about supporting and integrating with most existing infrastructure orchestration systems like VMware, OpenStack, Kubernetes, and any higher layer orchestration system like DNS Manager or NAV orchestration in the manual layer. So quickly to summarize Contrail architecture in one slide, you have a logically centralized but physically distributed controller, which is actually composed of multiple components. The configuration module, which stores all the config and compile high-level abstracted configuration into lower-level commands that are maintained by the controller. The controller, which programs all the states in the distributed vRouters that run inside each compute node. The analytic engine, which collects all the state information from all the vRouters. And the Tor service node, which manages top-of-rack switches to connect the bare metal resources. So all these different software modules compose collectively the Contrail controller. Now the controller is using primarily OVSDB to configure top-of-rack switches, BGP and netconf to interrupt with the data center gateway that provides connectivity outside of the data center, and XMPP towards the vRouter. In the example below, with the configuration that is shown here, for example, we decide to bring all the blue bare metal servers and all the blue VMs and containers in the same virtual network. Same for all the red bare metal servers, red VMs, and red containers. And all the traffic between the blue endpoints and red endpoints have to be redirected to a virtual firewall that sits on the server on the right side. So as a result, what you get is a multi-tenant network segmentation for virtual machine containers and bare metal servers, automated policy-based insertion of firewall virtual machine with layer 4 to layer 7 security policies enforced within the vRouter. So here, just one last slide. I would like to contrast the way packets are processed using software vRouter, whether you're using the kernel vRouter or the DPDK vRouter. Basically, all the traffic is processed on the left side by the software router here, versus on the right side, when you're using a SmartNIC, you are leveraging the accelerated vRouter implementation that is running inside the SmartNIC and basically offloading all the work that is done normally by the software vRouter. Okay, and Danny, you want to take over from here?
Yeah, absolutely. So thank you for that wonderful introduction to Contrail. And as you guys can see, Contrail is a very feature-rich environment for network virtualization and applications, as well as orchestration. But what I'm going to talk to you about today is our SmartNICs and how they can make Contrail even more effective and even lower total cost of ownership for your networks. But first, a brief word about Netronome. Everybody knows Juniper. Not necessarily everyone's heard of Netronome. So very briefly, we're a pioneer in the network flow processing area. And we have kind of led the charge for the development of what we like to call SmartNICs, or network interface cards that are programmable and have data plane, networking, and security intelligence that you can apply at the NIC level. We're about 200 people and do about $90 million in revenue year over year. And we're very pleased to be working with Juniper on their Contrail product. So why do you need a SmartNIC? So we have to look at a few things that are creating challenges within the NFV arena today. And the first is everyone's seen the chart on the left, which shows the incredible growth that we're seeing in mobile data these days that's driving the amount of throughput that our networks have to be able to sustain. But on the right side, something that is also interesting and creates a bit of a dichotomy is that Moore's Law, which we all are familiar with from Intel's Gordon Moore from many, many years ago, stated that transistors, or a number of transistors available, will double every 18 months. And that, for the longest time, held true to gospel. But over the last several years, that law is beginning to break down. And we're not seeing, as process technology improves, we're not seeing that same growth in number of transistors at the same price point. So server CPU resources aren't getting cheaper like they used to, but certainly there's no abating the growth in network bandwidth. So that's creating a challenge. And what's happening is, as the amount of bandwidth grows in networks and as virtualization takes over, our compute servers aren't just compute servers anymore. They're real networking applications and appliances. They need to be able to understand network topology. They need to be able to switch and route traffic. They aren't just a single point where you're passing packets into an application plane anymore. You have to demultiplex into the appropriate VM. You need to apply security policy. And all of that costs CPU cycles. It's not free. And so the CPU cycles required for networking are going up leaps and bounds. But as I mentioned in the previous slide, the CPUs aren't getting bigger and faster and cheaper anymore. So what that ultimately creates is a situation where the CPU cycles for networking are going up and the available cycles for applications are thus being diminished. You know, it's a fixed resource, and if you take away from one, you have to give it to the other. And so networking networking costs money, but it doesn't create revenue. What creates revenue are the actual applications, the VNFs that you want to run in your network. So every CPU cycle that's used up for networking is one less CPU cycle that you can actually use to generate revenue. So we need to find a way of addressing this issue. And to further exacerbate the problem, it's the servers that cost the money in the network. This is a chart from Amazon AWS. And as you can see, 80+% of monthly data center costs are attributed to servers, as well as the power and cooling necessary to operate that infrastructure. So if we are really serious about getting more efficient, having more revenue generating capability, we need to get more out of the server resources that we are building into our network infrastructure. So one way of dealing with this is throwing CPU resources at the problem. And clearly, from the previous slides, you'll be able to realize that just mathematically doesn't add up. It's not an efficient way of dealing with the problem, and it's certainly not an economical way of dealing with the problem. So as has happened in multiple other networking and compute technologies in the past, when something becomes a bottleneck, you take it out and you build dedicated hardware to address the problem. And we saw this with digital signal processing. So we have DSPs to handle those types of workloads. We saw this in the graphics industry, where we have GPUs that were originally designed just for handling graphics, but now are increasingly used as very, very heavily multi-core processors for machine learning and scientific computing. FPGAs are often used to offload compression, cryptography, and so forth. Well, at Netronome, what we do is we've designed custom network acceleration technology that is very, very specific to the workload at hand. So it's built for packet processing, security, storage, cryptography. And it's a very, very highly multi-threaded processor technology that's got 80 to 120 individual processing elements specifically designed for networking and security. And those are optimized as coprocessors to augment the generalized x86 compute where our actual VNFs run. And you could question the need for acceleration and say, well, yeah, I'm happy. This is simple. I'm just going to continue with my generalized compute model. But, this isn't just a metronome phenomenon that we're trying to push along with our good friends at Juniper. The big guys out there, Amazon, Microsoft, Google, I'm sure if you follow this area of the market, you've noticed some of these announcements. They've all employed some varied form of acceleration technology into their global data center compute infrastructure. Now, what's interesting about these guys is they're ginormous, of course, and they have the necessary R&D budgets and expertise to develop their acceleration technologies on their own. Most of our potential customers in the deploying cloud technologies and network functions virtualization do not have the resource or expertise to go off and build their own accelerators. So the rest of the market needs an off-the-shelf solution to provide that level of acceleration that's going to allow them to offload the dramatic growth in bandwidth and at the same time give resources back to their application layer. So at Netronome, what we've developed is our family of Agilio Smart Network Interface cards, or Smart NICs. And these are low-profile, sub-25-watt Gen 3 by 8 PCIe adapters that fit into any standard off-the-shelf compute node. They're available in dual 10, dual 25, and dual 40 gig options to address all the different infrastructure connectivity needs that you as customers may have. And as I mentioned, they are not just hard-coded ASICs, but rather they're completely programmable networking and security optimized devices based on our own silicon containing up to 120 programmable flow processing cores. And the beauty of that programmability is that our Agilio server-based networking software can give those NIC cards various personalities simply based on a software load. So we have offload acceleration options for Open vSwitch, for a firewall, a stateful firewall load. And of course, what we're here to stress and talk about today is our Contrail vRouter offload software package. And the beauty of the solution is it brings the speed of software innovation to hardware. We're not programming general purpose processors, but these cores are programmable with Common C or the upcoming and more innovative P4 language, as well as extended Berkeley package filters. And the other beauty of the programmable aspect of the network interface cards is that they aren't built with a single personality in mind, and we can keep up with our partners' software innovation as well. So as Contrail comes out with new features, as they do every 4 or 6 months, we simply develop and implement the same exact features down on the Agilio server-based networking cards at the same time. So we're never out of sync with the data planes that we're trying to offload and accelerate. And of course, from an orchestration and control perspective, we are completely controllable via OpenStack and other cloud orchestration tools. And in fact, from the tool perspective above the northbound interface, when they're looking down at the networking-based infrastructure, where we, and of course the vRouter exists, they don't even see any difference. All they see is the vRouter component, and we've got the hooks that allow us to tap into their data plane and actually pull that infrastructure down into the network interface card where we can accelerate it. And I'll go through that architecture in more depth here in a few moments. So what are the acceleration benefits of the SmartNIC? So first, from a stack perspective, what kind of performance improvements can we expect to see? So of course, we've got the Agilio vRouter platform operating on the network interface card along with our vRouter software package. And sitting above that is the actual Juniper vRouter that Mark described in great detail to us before, that runs in either kernel or DPDK mode, that is running in software. And on top of that is the Juniper Control Controller. And of course, you've got the host of orchestration options that Mark walked us through. So this solution stack, if you will, provides some incredible advantages from a performance perspective and from a cost perspective. So first, by simply taking the data plane out of the software path, you can increase the core savings by up to 10 times. Because rather than having to waste potentially half of your server for actually running the data plane itself, that data plane is now offloaded to the SmartNIC. And all you need is possibly one core to operate the vRouter from a sort of control plane perspective, but all of that data plane forwarding happens directly in the SmartNIC. And it also performs up to 5 times of an I/O throughput gain. So I'll show us a particular graph on the throughput advantages later, but this solution can operate north of 25 million packets per second, whereas the software-only techniques typically top out at the 5 to maybe 7 million packets per second. The solution is completely mobile, and what I mean by that is it's transparent to the orchestration layer. So VNF's onboarding and mobility is completely maintained without any change. And of course, as I mentioned earlier, the solution is 100% programmable. So as we need to change features, change functions, add protocols, add different tunneling techniques, change behaviors, we can do so with simple firmware upgrades to the network interface card available in minutes time. Which obviously ends up at the end of the day with a 3 to 6x better TCO, saving a lot of cash for the actual applications themselves. Now, what does the architecture look like? So if you look above the dotted line, that would be very consistent with the way Contra vRouter operates today. So there's a kernel module, a user space agent, and of course that's the demultiplexing point to get traffic into virtual machines, all under OpenStack or some other orchestration and configuration model. Now, but what we've done at Netronome with the Agilio adapters is we've created hooks into the vRouter kernel module that simply allow us to replicate the table structures that the forwarding plane sees in software, and it moves them down to our networking and security optimized hardware in the SmartNIC itself. So LPMs, MPLS table lookups, exact match and wildcard flow tables, tunnel encapsulations, decapsulations, all of those data plane aspects can happen directly in the Agilio SmartNIC. So if you could think about things from a day in the life of a packet, as traffic comes in to the network interface card, be it on 10, 25, 40 gig interfaces, those packets are handled directly in the SmartNIC, and they are delivered into the virtual machines or the VNFs directly from the SmartNIC across PCIe, thus bypassing the Linux kernel forwarding plane entirely. And I always like to draw the analogy when discussing this type of offload in that if you can imagine a giant 8-lane highway, which is all of the resources that the VMs have access to on the compute node, the kernel or DPDK forwarding plane for vRouter can be like the 2-lane tunnel that has to get you into that 8-lane highway. So it's clearly going to be the bottleneck unless you throw substantial resources at the problem. So if you throw substantial resources at the problem from a compute perspective, well, you're just taking all that compute resource away from those VMs itself. So the simple way of not having the 2-lane tunnel into the 8-lane highway is by offloading that data plane and having an 8-lane highway all the way into the VMs from the network itself, bypassing the data plane in software, and thus giving all of that resource back to the compute nodes themselves. Now, another additional piece of functionality that's key to the solution is something that Netronome that we invented, I would say, and we call ExpressVirt IO or XVIO. And what XVIO is a technology that combines the benefits of VirtIO, SRIOV, and DPDK all into one package. And for those that aren't familiar, VirtIO is a paravirtualization technology that allows the VMs that are actually running in the compute node to essentially look down to the hardware in the compute node itself without any presupposed knowledge of what that hardware is from a driver perspective. So it provides a kind of a translation layer that the VMs, all they need to do is speak VirtIO, and they don't have to have any particular drivers installed for the hardware that sits underneath. Now, that's a great idea, but it's a Linux construct. And then again, it gets us back into the going through the Linux kernel networking stack or the vRouter networking stack in software to take advantages of VirtIO. Now, on the other hand, something called SRIOV, or Single Root IO Virtualization, exists that gives you a direct path from the network card itself into VMs, which is obviously a very, very high performance technique for getting data into virtual machines, but it suffers from drawbacks as well. It doesn't give you that flexibility that VirtIO does, and it essentially eliminates the match action data plane that vRouter provides to you down on the network card itself. So it's essentially taking packets in a very rudimentary form, demultiplexing into VMs. So you lose flexibility, you gain performance, and you also lose the independence that VirtIO gives you. Now, at Netronome, what we've done is we've combined these three technologies. So when packets come into the SmartNIC, as they traverse the PCI interface and are directed towards the VMs, the device thinks it's sending them via SRIOV. So it's sending them in that high-performance data path with the vRouter data plane sitting underneath. But a simple DPDK application exists that essentially acts as a translation layer and takes that SRIOV data path and creates a VirtIO instance that the VMs looking down can see. So it brings all of the performance of SRIOV as well as the flexibility and ubiquity of VirtIO together in one package. And it's definitely a unique feature that we have in industry. So 2 more brief slides, and then we'll move on. So one of the benefits of this approach is that different VMs have different profiles from a performance perspective. Some are very, very high throughput, but don't do a lot to traffic. Others require a substantial amount of processing to be applied to the traffic, but don't see essentially necessarily high amounts of data or high millions of packets per second. And to meet those different profiles, operators are sometimes required to implement different technologies. So for the high throughput apps, they need to deploy SRIOV. For other applications that aren't as high throughput but require a lot of CPU, they may implement vRouter in kernel mode, and other times vRouter in DPDK mode with various numbers of cores assigned to that data plane is the more efficient way of doing things. But this hodgepodge approach creates a very, very inefficient network from an orchestration technology perspective, as well as from an operations. A more appropriate approach is when you're using combined vRouter with Netronome Agilio, as well as XVIO. It gives you the performance of SRIOV. It gives you the advanced networking features that Contrail brings to the table. And XVIO gives you the hardware independence and mobility that VirtIO gives you. So you can place workloads anywhere. You can migrate them anywhere. You can support the multi-tenancy and security that's required for these types of networks. And you can scale them as needed. As you just simply add compute, you've got one type of networking technology under one layer of orchestration that is perfectly suited for all the varied VM application profiles, as different as they may be. So where the rubber meets the road is performance. And at Netronome and along with our friends at Juniper, we've measured the performance of Contrail vRouter in several different implementation instantiations. So kernel vRouter is the slowest, doing it a couple million packets per second. DPDK vRouter is far more efficient. And as you can see, doing with 4 or 8 CPU cores assigned, you could do between 5 and 10 million packets per second in the machine, with the rest of the cores of the device dedicated to actually running the VMs and the VNFs. But combining CloudTrail vRouter with Agilio SmartNICs, you can achieve north of 20 million packets per second. And it's line rate at anything 128 bytes and above, while only using 1 CPU core. So you've taken 2 different axes of performance degradation away with one single solution. You've given all of the CPU resource practically back to the application plane for generating actual revenue based on your VNFs, and you've increased the size of the data plane of getting throughput into those applications by up to 5 times more, which ultimately results in improved total cost of ownership. So we've actually measured with a sophisticated modeling tool that we developed the TCO for various different VM workloads. So as I said before, not all VM workloads are made the same. And for DNS or web server VNFs where they don't see a lot of traffic, you can see a 3x TCO. And it's even more incredible for very, very high throughput applications that the kernel or DPDK vRouter data plane and software was the low man in the totem pole from a throughput perspective. So the value proposition for combining Agilio SmartNICs, our vRouter software, with our friends from Juniper's CloudTrail is that it's a complete offload and acceleration of that vRouter data plane, where the packets are fully processed and handed to VMs directly, bypassing all hypervisors and software processes, while retaining the benefits of VirtIO. This high-performance networking data plane gives you up to 30 million packets per second to the host, which could be 40 times the performance of some of the software-only solutions we've talked before, which amounts to about 6 times the cost per unit core savings over other approaches. And in offloading the XCPU cores is just something that's so obvious. It allows with more applications, it allows those applications to run faster, freeing up potentially half of the server resource that was previously dedicated to networking data planes. And now additional workloads that might not have even ran on the software vRouter become possible. And with that, for the final slide, I'll pass it off to Mark, and then we'll take some of your questions happily. So Mark?
Yeah, thank you, Danny. So just to wrap up, CloudTrail has been around on the SDN scene for a few years now, and our market leadership has been consistently recognized by the market. A year ago, Heavy Reading published a paper on telco data center transformation, where CloudTrail was rated close second behind Cisco, and more recently, last December, IHS published a survey on cloud and DC security strategy, and CloudTrail was rated #1. So what we believe is that by combining the flexibility and feature richness of CloudTrail with all the benefits of high performance that the Netronome Agilio SmartNIC is giving you, you're really getting the best of both worlds. Danny, I don't know if you want to add some last word.
Now, I just want to thank everybody for their kind attention. I hope everybody found this interesting, and we'll pass back off to our friends to talk about some questions and answers that you may have, I think.
Yeah, thank you very much. And just a reminder for the audience, in order to ask questions, you can send them in via the questions widget. So that means just you simply type them into the box at the top left-hand corner of your screen there and hit submit. And we're going to try and get to as many of these questions as we can in the limited time that we have left. So I'm going to start off with this question here. If 2 routers on a PT-PT link have SmartNIC on that link, can the L2 protocol be programmed to something other than Ethernet? Example, HDLC. Who wants to take that one?
I'll take that one. Right now, our SmartNICs only do support Ethernet, but there is no reason that other data plane technologies can't be supported in the future. Right now, we have Ethernet only support, but that's not. There's no mitigating factor for that.
Okay, lovely. Thank you for the answer. Moving on to the next question here. This is, can we have a single Open Contrail vRouter instance, a scale to run over multiple servers?
So let me take this one. vRouter is a data plane part of the solution. So it's really the equivalent of what is a line card inside a traditional router. So you definitely need a line card to connect the various servers or routers between themselves. So basically, you need this vRouter in every compute node. But again, this is just a data plane part of the overall solution. It does not include a control plane, which is centralized on a small number of dedicated servers that are processing all the signaling and control and configuration.
Lovely. Thank you very much. Audience members, please do keep those questions coming in. Moving into another one now. Are there service providers with Netronome and Contrail in production right now?
So I'll take that one. As you guys know from the presentation, Contrail it's the gold standard out there right now. So there are a lot of carriers and so forth that have Contrail deployed. At Netronome, we are working with Juniper. Our solution is going to be generally available very shortly, actually towards the end of the month. And so at that point, we'll be able to publicly announce some deployments with carriers. But suffice to say, we are in trials with some of the largest carriers in the world right now, some of them which were mentioned, and some of them you'll be hearing about very, very shortly from us.
Lovely. Okay, this next question here is this presentation going to be available to view later? I think I can actually answer this one myself. This webinar is being recorded, and it will be available to view on demand as well for 12 months following this broadcast. So you will be able to catch up at any time. The link will be sent through to everybody following this broadcast. Moving on to this next question here. With vRouter, SmartNIC, and VM with SRIOV, who is going to be the L2 gateway? The vRouter on SmartNIC or a TOR SW as usual?
So let me cover this one. So once we have this solution, we will still support the current mode of operation to integrate bare metal servers by using our TSN, the top-of-rack service node that is basically programming the top-of-rack switch. At the same time, having this new solution with very high performance allows you to have a layer 2 gateway which would be based on a server with a very high performance, something that you would not be able to achieve in terms of flow throughput by using software-only vRouter. So you will have the choice, basically. It's just another possible solution for this requirement.
Okay, thank you very much. Do keep those questions coming in. We have time for a couple more here. This one is, what is the difference between the Agilo SmartNIC and the NFP 4000 series in Contrail environment?
The answer is a good question. The answer is there is no difference. Just a terminology sync, the Agilio SmartNIC family is available in two different variants or families, the Agilio CX and the Agilio LX. Where the differences between those, as mentioned before, they're all based on Netronome's programmable network flow processor silicon. The chip names are the NFP 4000 and the NFP 6000. So the NFP 4000 is the chip that powers the Agilio CX family, and the NFP 6000 is the silicon that powers the Agilio LX. So it's just a terminology thing. It's the NFP 4000 is on the Agilio SmartNIC.
Okay, thank you very much for that answer. Moving on to the next question very quickly. This is, would gains for OVS be similar to those shown for vRouter?
Yeah, the answer is absolutely. while we are very fond of our relationship with our friends at Juniper, we also do support OVS as mentioned, and the architecture is identical. It's the same type of offload acceleration that you would see in the vRouter case, albeit with a different data plane. So yeah, the gains for OVS, and we can share those one offline if you'd like, but the gains for OVS are almost identical, both from a throughput perspective and from a CPU savings perspective for OVS as they are for vRouter.
Okay, lovely. Next question here. What are the additional functionalities of the FW versus a Linux FW based on IP tables?
So let me take this one. The forward capabilities that the vRouter supports are, I would say, roughly comparable with what Linux firewall can do based on IP table, which is like 5 tuple based on security rules with stateful flow recognition. Having said that, IP table is well known to have very serious performance and scaling limitations, while vRouter can literally scale without any performance impact once you add more and more firewall rules on your vRouter.
Okay, thank you very much for that answer. Oh, sorry, go on ahead.
And also, it's really just more about scaling and performance versus functionalities.
Okay, thank you very much. Moving into the next question now. Does the solution itself improve the VNF performance?
Well, the solution does improve VNF performance from one aspect, and I think I know where you're going with this question. I'll be so presumptuous. It makes the VNFs, it gives the VNFs more resources. It doesn't magically make the VNF operate faster per se. It doesn't change the VNF architecture or software implementation. So it just gives the VNF more resources on which to do its job. But that being said, we have had folks from various VNF vendors that have inquired about the ability for us to offload portions of the VNF itself to the SmartNIC. Now, that's not something we've done thus far, but we're happy to work with any vendors on examining that possibility of tighter integration of vRouter, Contrail vRouter, the VNF itself, and moving some of that functionality down to the SmartNIC. So more efficient load balancing is something that we've discussed. Moving part of the application processing down to the NIC itself, or other things that we've discussed, and that would improve the VNF performance itself. But the main gains are just by giving it all of that resource back and being able to feed it at a much higher rate. And we've seen, if you guys are kind enough to go take a peek at the announcement that we made with Juniper, ourselves, and a company, a VNF vendor called Affirmed Networks at Mobile World Congress last week, that will give some really good information on how we took a particular VNF, it made it perform a lot better.
Okay, lovely. Just enough time for one very quick last question here. Can we expect integration also with VMware NSX?
So again, that's more question for Danny, right?
Yeah, good question. It's funny because Mark and I were just talking about this one in email yesterday or the day before. So yeah, they support VMware NSX now, they being Juniper, I'm sorry. And we absolutely have plans on integrating tightly with that environment right now, albeit that support isn't there today. But that's definitely a roadmap item. And of course, as we engage with customers, we take everybody's feedback into mind, and we will put things into the roadmap in due course and due priority based on our engagements with the folks, of course, on this call.
Okay, thank you very much. That brings us to the end of our Q&A session. Sorry to everybody whose questions didn't get answered, but those will be forwarded on to Netronome, and you can expect an email response shortly, so thank you. That just leaves me to thank our speakers, Daniel, Mark, and Glenn, for what was a great presentation, and to thank Netronome for sponsoring this session. Once the webinar ends, today's survey will appear in its place, and we would ask that you could stay behind to answer the questions in there. Your feedback is important. To the attendees, you will receive an email shortly telling you how you can access the on-demand version of this webinar. As I mentioned earlier, you can access it through our website too, which is www.business-review-webinars.com. We do look forward to sharing further webinars with you, so please keep an eye out on the website that I just mentioned, and follow us on Twitter at BRWebinars for daily updates. And of course, you can join our LinkedIn group as well, Business Review Webinars. Thank you all once again, and I hope you all have a great day.